Okay, back again. A little bit more multiplication for us. We've learned lots of different strategies to solve these multiplication problems. Today's lesson is going to be using a larger number with the same strategies. So we're going to go ahead and see how this works. This is just an extension of what you've been doing for the week. So this one should be clicking in your brain and making a lot of sense. Today is Laura's birthday and she's 9 years old. Except for leap years, there are 365 days in 1 year. How many days old is Laura? So we're going to be finding 365 times 9 because she's 9 years old, and in a typical year there are 365 days. So first thing it asks us to do is estimate. Okay, for this particular problem, I'm probably going to leave the 9 alone because I think that that's pretty easy to work with, or you could estimate it as a 10, whatever you feel like you need to do. For 365, I'm going to go ahead and say, let's make this one 400. Let's round to the largest place value spot. That's one of the easier ways to estimate. So if we do that, 4 times 9 is 36. 2 zeros here, 2 zeros here. So we're getting 3,600 as an estimate. Like I said, you can use different numbers. You could make this 370. That would be pretty close to 365. You could use a 10 here, and that would be 3,700. So as long as your estimate is close, we're okay. They're just asking us to make sure we can get something that's reasonable. So the math problem says 365 times 9. Now this process is the same whether you have a single digit number here, a double digit number, or in this case a triple digit number. We're always going to take the same steps. So I'll go ahead and draw in the boxes that you have on your page, so that makes it a little bit easier here. Okay, so we've got that all set up, and then we've got our answer down here. Okay, so what they're asking us to do at each step here is a little bit different than regular math. So we're going to follow along here. This one says multiply 9 times 5. The next step says multiply 9 times 60. And the last one says multiply 9 times 300. This is kind of using the partial products that we learned before. Okay? The way that they have this drawn out, I'm going to put it up here for you, because it makes more sense to me in my brain if I have it set up like this. Remember, we did this with our place value spots. We decompose a number. So the number 365, if you decompose it, there are 300, then 60, then 5. Okay? That's what this is doing, basically. So 9 times 300, 9 times 3 is 27, with 2 zeros. 9 times 60, 9 times 6 is 54, 1 0 here, 1 0 in your answer, and this last one is 9 times 5, which is 45. This is going to make more sense with this, the way that they have this set up. This is not the way you do a typical multiplication problem, so it's important that you watch me here. They're doing it more like partial products, okay? We're still going to start with our ones, which is 9 times 5. They're writing it down here like this, okay? Not like our typical problem, but follow along with this one. 9 times 5 is 45. If you notice, that's this box right here. This next step says 9 times 60, and the reason they're doing that is we'd be multiplying the 9 times 6, and we would have added a 0. So here we are, 9 times 6 is 54. Add our 0. That's this piece. And the last one is 9 times 300. So 9 times 3 is 27 with 2 zeros. Okay, that piece is this piece. Now they're asking us to add those. 5, 8, that's 12, carry my 1. So it's 3,285. Now our estimates were high, but that's because we rounded our numbers up, right? That's why our reasonable answer was a little bit high, but that's okay. So Laura is 3,285 days old. We can fill it in here. And then at the bottom, our product, 3,285, is close to the estimate, whichever estimate you chose to use, okay? So this is showing us that partial products. It's just another way to look at it. On the back, this is showing you a more traditional example of how to do this multiplication problem. Rather than the partial products they showed us on the front, we're going to do this like a regular multiplication problem, like you guys have been doing. So let's go ahead and take a look at that. So we have, example 2 says find 3 times 1,175. So they set it up like a regular problem. The larger number always goes on the top with the smaller number on the bottom. That just makes it easier for us. So this time we're going to go ahead and take it through like a normal multiplication problem and not use partial products. Okay, so in a regular multiplication problem, we start with the ones. 5 times 3 is 15, so the 5 would be here, the 1 carries up. 7 times 3 is 21, plus 1 more is 22, so the 1s stay here, the 10s carry up. 7 times 3 is 21, plus 2 more is 23, so the 3s stays down here, the 2 goes up here, 3 times 1 is 3, plus 2 is 5. So we end up with 5,325. All right, let's go ahead to the bottom part and do the last two problems. So I'm okay with whatever method that you want to do for these guys. I find that it's easier to do the traditional math. If you'd like to, you can do the partial products, whether it's writing it out with the different levels or whether it's using the boxes to help you. We'll do it a couple of different ways, okay? Start with your ones. 5 times 2 is 10. Carry my 1. 2 times 3 is 6. Plus 1 more is 7. And 2 times 1 is 2. This same problem, if we were to write it out with partial products in the boxes, I think this one's a little bit easier to see. We have to decompose this number. So it's 135. So that would be 100, 30, and 5, right? Each place value spot has its own place. That means that inside this box would be 2 times 100. This box would be 2 times 30. And this box would be 2 times 5. Let's go ahead and find those products. 2 times 100 is 200. 2 times 30 is 60. And 2 times 5 is 10. Then all we have to do is add those partial products together to get our answer. So that would be 270. And you'll notice we got the same answer no matter how we did the problem. Let's go ahead and do the second one. 532 times 6. 6 times 2 is 12. Carry your 1. 6 times 3 is 18. Plus the 1 you carried, that would be 19. So the 9 goes there, the 1 goes up. 6 times 5 is 30. Plus 1 is 31. Now same thing, if you want to do it with partial products over here, you can. We just have to set it up the right way. So if we decompose 532, that's going to be 500, 30, and 2. And then we just need to figure out the partial products. So this box would be 6 times 500. This one would be 6 times 30. And this one would be 6 times 2. And when we find those products, 6 times 5 is 30 with 2 zeros, right? 6 times 3 is 18 with 1 0. And 6 times 2 is 12. And then we'll come over here and add our partial products together to get our answer. So when we do that, we get 3,192, which is the same answer we got the first time we went through it. So it's up to you guys which particular strategy you'd like to use to help you solve these problems. Whatever works best for you is fine with me. I just like to be able to show you the different strategies so you can find something that works best for you. If you have any questions, mvaw123@gmail.com or through Class Dojo. Thanks.